Hi everyone, I'm Nadia and today I am come up with a brief session of machine learning. In today's world where data is abundant and complex, machine learning has become a powerful tool for unlocking valuable insights and making predictions. Let's get started. Machine learning is a subset of artificial intelligence that focuses on training machines to learn from data and improve their performance over time without being explicitly programmed. Here, the term used explicitly programmed. What is meant? Explicitly programmed means that a system or software is built by writing a specific instructions or code to define its behavior. In this context, explicitly indicates that the rules and instructions are directly specified and defined in the programming code, leaving little room for the system to learn or adapt on its own. So that in case of machine learning, machines are equipped with algorithms that enable them to analyze vast amounts of data, identify patterns, and make intelligent predictions. By training machines to learn from data, we can uncover hidden patterns, gain deeper insights, and make more informed decisions. In simple terms, machine learning is a technique for teaching machine how to learn from data and improve their performance over time. Now we will explore different types of machine learning with real world example. Machine learning can be broadly categorized into three main types: supervised learning, unsupervised learning, and reinforcement learning. Let's explore each of these types and see how they are applied in real world scenarios. Supervised learning is the most common type of machine learning where the model is trained on the labeled data. The data consists of input features and corresponding output labels. The goal is to learn a mapping function that can predict the correct label for new unseen data. For example, in email spam detection, a supervised learning algorithm can be trained on labeled emails as spam or not spam to classify future incoming emails. Second is unsupervised learning. Unsupervised learning, on the other hand, deals with unlabeled data. The model's objective is to find patterns, structures, or relationships within the data without any predefined labels. Clustering is a popular technique in unsupervised learning where the algorithm groups similar data points together based on their inherent characteristics. An example of unsupervised learning is a customer segmentation, where a retailer can group customers into different segments based on their purchasing behaviors without prior knowledge of specific customer profiles. Next is reinforcement learning. It takes a different approach by training an agent to interact with an environment and learn through trial and error. The agent receives feedback in the form of rewards or penalties based on its actions, and its goal is to maximize the cumulative reward over time. A simple example of reinforcement learning is training a virtual character to play a game. Let's consider a game where the character needs to collect as many coins as possible while avoiding obstacles. Initially, the character doesn't know how to navigate the game environment effectively. Through reinforcement learning, the character starts with random actions and receives feedback in the form of rewards or penalties. Whenever the character collects a coin, it receives a positive reward, encouraging it to repeat the action. Conversely, if the character hits an obstacle, it receives a negative penalty, discouraging that action. As the character explores the game environment and receives feedback, it learns to make better decisions to maximize its reward. Over time, through trial and error, the character develops strategies to collect coins efficiently and avoid obstacles. Now that we understand the types of machine learning, let's explore the key steps involved in a typical machine learning project. These steps form a general workflow that guides the development and deployment of machine learning models. The first step is data collection. High quality and relevant data is crucial for training accurate machine learning models. This involves gathering data from various sources, ensuring its integrity, and organizing it in a structured format. Once the data is collected, the next step is data pre-processing. This involves cleaning the data, handling missing values, dealing with outliers, and transforming the data into a suitable format for machine learning algorithms. Data preprocessing plays a vital role in ensuring the quality and reliability of the models. After data preprocessing, the next step is model selection. This involves mach- choosing the appropriate machine learning algorithm that best suits the problem at hand. There are various algorithms available, each with its strength and limitation. The choice of the algorithm depends on factors such as the type of problem, the nature of the data, and the desired outcome. Once the model is selected, the training process begins. This involves feeding the model with the pre-processed data and allowing it to learn from the patterns and relationships present in the data. The model adjusts its internal parameters iteratively to minimize error and improve performance. After training, the model needs to be evaluated to assess its performance. This is typically done using evaluation metrics that measure the accuracy, precision, recall or other relevant measures. Evaluating the model helps us understanding its strength and weakness and guide further improvements. It's important to note that machine learning is an iterative process. The evaluation results may lead to reiterating previous steps, such as refining the data preprocessing techniques, trying different algorithms, or adjust model parameters. This iterative cycle helps in improving the model performance and achieving better results. By following these key steps and embracing the iterative nature of machine learning, we can develop robust and effective models that can make accurate predictions and valuable insights. Machine learning has transformed various industries, enabling powerful applications that benefit our daily lives. Here are a few real world examples of machine learning in action, like healthcare, finance, e commerce, transportation, natural language processing. Let's explore some of these challenges and discuss the exciting future of machine learning. One of the challenge is biased data. Machine learning models learn from the data they are trained on, and if the data contains biases or inaccuracies, it can lead to biased outcome. It's crucial to ensure that the training data is representative and free from any biases to avoid perpetuating unfair or discriminatory decisions. Another challenge is the interpretability of machine learning models. Some complex models, such as deep learning models, are often considered black boxes, making it difficult to understand the underlying reasoning behind their predictions. Ethical considerations are also important in machine learning. We must ensure that AI systems are designed and used responsibly, respecting privacy, security, and fairness. It's crucial to have clear guidelines and regulations to govern the ethical use of machine learning technologies. Now, let's take a glimpse into the exciting future of machine learning. One area of immense progress is deep learning, a subfield of machine learning that focuses on training deep neural networks. Deep learning has achieved remarkable breakthrough in image recognition, natural language processing, and other complex tasks, opening up new possibilities and applications. Natural language processing is another exciting field within machine learning. It enables machines to understand and generate human language, enabling chatbots, language translation, sentiment analysis, and much more. NLP holds great potential in revolutionizing how we interact with machines and information. Additionally, explainable AI is gaining attention, aiming to make machine learning models more transparent and interpretable. Explainable AI techniques allow us to understand why and how a model makes certain decisions, providing insights and accountability. These advancements and future trends in machine learning hold promise for solving complex problems, improving decision making, and enhancing human machines interactions. In this video, we explored the basics of machine learning, definition, types, real world application, and the challenges and future trends. Next, we will be sharing more in depth content, practical tips, and exciting updates to help us on our machine learning journey. Thanks for listening. If you found this video helpful, please give it a thumbs up and share it with others who might benefit from it. Once again, thank you.